All right. Okay, so I hope that we are live. Just let me check it once. Perfect. Okay. So you're fine. Hi, hello, good evening, my dear students. How are you all? So I hope that everybody is fine and very ready with all the preparations as your exams are very soon going to start, right? So students, first of all, I would like to wish you all the very best for your examination preparations, right? You know that your term to examinations are very soon going to start. So I hope that everybody is in the best of their preparations, and we an academy are again back here bringing out the amazing sessions for your preparations and to help you and to guide you throughout your sessions. Okay, so first of all, about me. So I am Ritika, a chemistry educator on an academy. I have completed my engineering in electronics and communication, and right now I am here teaching you all chemistry, right? So first of all, I welcome you all, and there's a small request for all of the students. Now, students, if you need the class notes and you need the homework, you can join me on my Telegram channel. The link is provided to you in the description box. So, kindly join me on the channel, and also you can join the official Telegram channel of the Unacademy to receive all the regular updates about the classes, about the sessions, about the offers, etc., that we have here at an academy. Okay, so please try to join these and please try to share the links. And now we will be starting with our chapter. So see, today what are we going to start? We are going to learn about the gas laws. As you know, the gas laws is one of the very important topics of your term 2 examinations. Okay, so we are going to cover certain part of the gas laws. All right, now what are the topics that we are going to cover in the gas laws today? So let us see. Yeah. Now today we are going to first of all cover the properties of the gases. Okay, we are going to see the behavior and the characteristics of the gases. Then we will be seeing the relationship between temperature, pressure, and volume. We will be seeing the gas laws and the parameters which govern the gas laws. Okay, so this is our very first session of the gas laws. Kindly make sure you attend it, and also please try to share the link with your friends and all the students as much as possible. So let's quickly start without wasting any further time. So what is gaseous state? Now, as you know, the gaseous state is one of the state of matter. Okay. Now, there are some of the particular properties, which is interparticle attraction, it is weak, and the interparticle space, it is very large. Okay. Now, let's suppose this is a container in which the gaseous molecules are present. Okay. These are my gaseous molecules. Now what happens over here in the gaseous molecules, the particles, they are spread out. Okay, they are having great interparticle space between them. Okay, and because of this large interparticle space, what happens? The attractive force, okay, the attraction that the molecules can exert on each other, it is very low. Okay, so the gaseous state of matter is the state in which the interparticle space, it is very large, and therefore the interparticle force of attraction, it is very low. Okay, and because of this low or less force, the particles, they can randomly move in any direction. They are just moving in entire space which is available to them. So that is the state which is known as the gaseous state. So gaseous state, it actually occupies the whole space, okay, of whatever vessel or whatever container we have kept it in. Okay, so it just takes the shape of the vessel. Now talking about the gases, now gases, they show same kind of behavior under similar condition of temperature and pressure. Okay, now they are not dependent on their nature, on their color, or on their odor. If we change the temperature or pressure, they will be showing similar changes. Okay, now talking about the first of all comparison in properties of solid, liquid and gas. Okay, so as we know that these are the three basic states of matter, so we will be seeing some of the properties which separate or which differentiate solids, liquids and gases. All right. Okay, let's quickly start with the first property, that is shape. Okay, now if I talk about definite shape, okay, so solids, liquids and we have here gases. Okay, now if I talk about solid, they have got a particular or definite shape and volume, right? Solids, they have got a particular shape also and a particular volume also. Liquids, they do not have a shape, so no definite shape, but their volume is fixed. Okay, fixed volume we can say. Okay, and in the case of gases, there is no shape, no fixed volume. Correct? Okay. Then if I talk about how are molecules packed in the case of solids, so molecules are packed tightly. Okay, so molecules are tightly packed. Okay, then if I talk about liquids, the molecules are a bit loosely packed. Okay, and in the case of gases, the molecules are far apart from each other. Okay, that is why they are always in a random motion. Okay, next if I talk about the intermolecular space, so I'll just write the heading: solids, liquids and gases. Yeah, so if I talk about the intermolecular space, it is minimum in case of solids. Okay, if I talk about liquid, they are having a bit more. Okay, so I can write that comparatively more than solids, so they are having some of the spaces between their particles, so we can say that liquids, they have comparatively more intermolecular space than solids. And if I talk about gases, so they have maximum interparticle or intermolecular space between the particles. Okay, because here the space, it is minimum, so if I talk about the force of attraction, the intermolecular force of attraction, it is maximum. Okay, why? Because the particles are closely packed, and since the particles are closely packed, they exert the attractive force on each other. Okay, in the liquids, it is comparatively less than solids. And if I talk about the gases, they do not have a negligible force of attraction between the particles. Okay, then if I talk about solids, they cannot flow. Okay, liquids, they flow, but flow from a higher level to lower level. And if I talk about gases, they can flow freely in all directions. Okay, so the gases, they flow freely in all directions. So these are some of the properties which differentiate solids, liquids and gases. Hope that is very much clear. Now let us talk about some of the properties or the characteristics or the behavior of the gases. Now we all know that gases, they are composed of molecules or particles. Okay, now see over here we are having, let's say that this is our container. Okay, now this is our container and here we are having the particles. Okay, these particles are far apart. Okay, and they are in a constant random motion. Okay, right, so the particles of gaseous state, they are constantly moving from one place to another. Right, now the kinetic theory, it helps to explain the relationship between pressure volume and temperature. Now this theory tells that what is the effect happening on one of the parameter when the other two parameter or one parameter changes. Okay, now let us see what is the characteristic or how the property changes. Now, before that, first of all, we will be discussing the different things or different properties of gases. Now, if I talk about composition of gas, so gases, they are made up of molecules, okay, and these molecules, they are in constant random motion. Okay, so the molecules of gases, they are in constant random motion. Next, we learned that gases, they do not have any fixed shape and volume. Okay. Third property is the gases, they exert pressure in all directions. Now, how does this happen? Let's suppose this is my container, okay, and I am having gaseous molecules over here. Now, as we learned that the particles, they will be in constant random motion, okay, so they will collide with each other and they will also collide with these walls of the container. Okay, and because of these collisions, the gaseous molecules, they exert a pressure. Okay, so gases, they exert pressure in all the directions. Next is gases, they are highly compressible. Now, talking about how are gases highly compressible. So you can see that there is, a good amount of interparticle space between the gases. Okay. Now, if we try to compress the gas, what will happen? The molecules, they will come closer. Okay. So when we apply pressure, the molecules, they will come closer, and that means the gases can be compressed. Okay. Next is the gases, they are highly expansible. Now, what do we mean by the expansion of gases? Okay, so when we, either decrease a pressure or we increase temperature. In these cases, what happens? The volume of gas, it increases. Okay. So when the pressure on any enclosed gas, we are reducing this pressure. Okay, the particles, they are moving apart. Okay, and since the particles, they are moving apart, they are increasing the intermolecular space, which means the volume of any gas, it is increasing. Okay, and if I talk about increasing in temperature, so when I'm heating the gas, okay, what happens? The kinetic energy increases, and since kinetic energy increases, the molecules, they start vibrating more frequently. Okay, which means they are moving now faster. Okay, and they are moving further apart from each other, and because of this, the volume of the gas, it increases. Okay, next we learned about the gases have low density. Okay, now if I talk about number of molecules per unit volume of gas. Now we learned that the particles of gases, they are spread apart. Okay, they are far apart, which means if I talk about any unit volume, the number of molecules will be very less. Okay, and that means the gases, they have large interparticle space, which accounts for their low density. Right? Okay, then it's they have the tendency of diffusion. Now, first of all, what do we mean by diffusion? Just a minute. Yeah, so diffusion is the process of gradual mixing of substances. What's the reason? By molecular motion. Okay, now why do gases, they have this property of diffusion? See, if I talk about the molecules of gases, they are having a good amount of interparticle space between them. Okay. Now what will happen, since I'll just draw it and show you over here. So see, if this is my container, okay, and I am having a particular type of gas. Okay, so this is my gas and the molecules, they are spread apart. Okay, now if I'm having any other gas, okay, if I have, let's say if I have sprayed a perfume, okay, what will happen? The molecules, they will be spreading in this way. Now what has happened over here, the normal air particles, okay, they had spaces in between them, and the perfume particles, they have taken the space from the between, right? So because of this, what happened? Intermixing. Okay, so the molecules, they came in contact and they mixed with each other, and this process, it is known as diffusion. Okay, so because of diffusion, the particles, they can mix up with each other. Okay, and the reason is molecular motion. All right, and then we have the next property, that is the gases, they can be liquefied. Now how can we liquefy the gases? So when we cool the gases, okay, on cooling, what happen? The kinetic energy of gas, it reduces. Okay, and when we apply pressure, okay, when we apply pressure on this cooled gas, what happens? The molecules, they come closer. Okay, and as the number of molecules increase per unit volume, what happens? We can say the gas can be liquefied. Yeah. So the gas liquefies. Okay, so how is it liquefying? When we cool the gas, the kinetic energy is reducing, and then further apply the pressure, the molecules, they come closer and the gas is liquefied. Okay, I hope that is very much clear. Next is the molecular motion, which shows the relationship between temperature, pressure, and volume of a gas. Now, we saw that according to kinetic theory, that the molecules of any substance, they are constantly moving. That means the molecules, they are in a constant random motion. Now, the energy which is possessed by the virtue of movement, it is kinetic energy. So since the molecules, they are continuously moving, they are having a kind of energy in them, which is kinetic energy, right? Now if I talk about the kinetic energy of any particle, it is proportional to the temperature. Okay, now according to this, what's the inference that we can draw? That if the, okay, first of all, kinetic energy, it is proportional to the temperature. Okay, absolute temperature. Now if the kinetic energy increases, what is the effect of temperature? Oh, I'm sorry, just a minute. Yeah, so if the temperature increases, what effect it will have on kinetic energy? Kinetic energy will also increase. Okay, now because the kinetic energy is increasing, what will happen? The molecular motion, it will increase. Correct? So as kinetic energy is increasing, the molecular motion is increasing. Now let's suppose we are decreasing the temperature. Now on decreasing the temperature, what will happen? The kinetic energy will decrease. And as kinetic energy decreases, the molecular motion, it will also decrease. Okay, now according to this concept, what should be the molecular motion when the temperature is 0? So when our temperature, it is brought down to 0, the the molecular motion, it should stop, it should halt. Okay, it should come to halt. Okay, now this is the theory, or this is the fact which is applied in defining the temperature of Kelvin scale. So the temperature at which the hi Aman, good evening. The temperature at which molecular motion it is completely stopping, or it completely ceases, just due to just according to theoretical concept on a Kelvin scale, this point it is known as absolute zero. So how to define absolute zero? It is the temperature at which molecular motion it is completely ceased or completely stopped according to theoretical concept. Okay, now if I talk about the absolute zero, it is equal to minus 273 degree Celsius. Okay, now if I talk about the temperatures lower than absolute zero, that is lower than minus 273 degrees Celsius, it is not possible. Yes, so absolute zero it is equal to minus 273 degrees Celsius, and there is no temperature which is possible below this level. All right, moving on to the gas laws. Okay, so if I talk about the gas laws, see, how is the gas going to behave under the conditions, or under the given condition of pressure, volume, or temperature? It is told, or it is described by gas laws. Okay, now there are three standard variables for the gas laws. Okay, now we can describe the whole behavior of gases by using these three parameters, and these three parameters are volume, temperature, and pressure. So these three parameters, they describe the behavior of gases. Now let's know about each of them one by one. If I talk about any given mass of gas, or let's say any fixed amount of gas, if I change any one variable, let's say I'm changing temperature, okay, there will be constant effect on the volume and pressure. Okay, so that means if I change any one variable from the three, it will lead to changing the other two variables also. Correct. Now let's know a bit about the three variables before moving on to the gas laws. Okay, let's start with volume. Now what is meant by volume, or how to define a volume? So volume, it is the space occupied by the gas. Okay, now in the case of gases, as we know that the gas it spreads out and it takes the whole of the space of the container. So in this case, the space that is occupied by gas, it will be equal to the volume of container. Okay, now if I talk about the units, okay, the SI unit of volume is meter cube. Okay, and we are also having some of the other units, just a minute. Yeah, so we are also having some of the other units such as liter, or we can say we have milliliter, we have centimeter cube, we have decimeter cube, etc. All right, and here 1 liter, it is equal to 1000 milliliter, which is equal to 1000 centimeter cube. So kindly remember the relations. All right, after that we have pressure. Now what is pressure? See, the molecules of the gas, they are in constant random motion. Okay, so because of this motion, they collide with each other, they collide with the walls of the container. Okay, so what is the pressure? It is the force that gas exerts per unit area where on the walls of the container. All right, now if I talk about the SI unit of pressure, we are having Pascal. Okay, and some of the common units that we are using is, okay, so the common units, we can use centimeter of mercury or millimeter of mercury. Okay, we are also using torr, which is named after Torricelli. Okay, now if I talk about the relation, 1 atmosphere, it is equal to 760 millimeter of mercury, or 76 centimeter of mercury, or it is equal to 760 torr. Okay, all right. Okay, thank you so much, Noor. Thank you. All right, next let's talk about the temperature. Now, what do we mean by, or how do we define a temperature? So temperature, it is the degree of hotness or coldness of any substance. Okay, so it is the degree of hotness of any gas in the terms of gases. Okay, and what are the what is the scale that we are using? We are using generally centigrade or Celsius scale, or we can also use the Kelvin scale. Okay. Okay, now in the examinations, you can be asked the questions from, you could be asked to convert the temperatures, right? So there is a particular relationship existing between the Celsius to the Kelvin scale. Now let us see what is the relationship. Okay, so if I need to have the temperature in Kelvin, what I will do, I will just add 273 to the temperature in degrees Celsius. And similarly, 4 degrees Celsius, just subtract 273 from Kelvin. Correct? All right, so students, now a very important information about Unacademy free special class. So first of all, why is it a special class? Because over there, are you teaching ICs? Yes, no. So we are going to have a session on 10th ICSE tomorrow from 1 p.m. to 2 p.m. Okay. So tomorrow we are going to do a very important session on nomenclature, so kindly don't forget to join. We are going to have a very important session from 1 p.m. to 2 p.m. You can also join the Telegram channel for more information. Okay, the link is provided to you in the description box. Okay. Now, talking about the Unacademy free special class. So, these are the classes, first of all, everybody can attend because these are absolutely free of cost. Okay, now what's so special about these classes? First of all, you can have real-time interaction with your educators using chat options and emojis. Okay, then you can also ask your doubts or you can ask your questions. There is a question tab, okay, which you can use. You can either type your question or you can attach the image of your question and you can discuss your doubts. After that, we have poll options. Okay, so poll options are just like MCQs in which you will be answering the question asked by educators, and we also have got a leaderboard, okay, so that you can compete with your friends. Okay, so these are some of the features of your Unacademy free special live class. Now, special class timetable for tomorrow. So see, tomorrow, that is 8th February, we are going to have a poll war on gas laws. Okay, so we are going to have a poll war, which means we are going to have many questions which you can use to revise. Okay, then on 10th February we are going to discuss periodic table, and on 12th February we are going to have a poll war on periodic table. So kindly note the timetable, note it down, and don't forget to join the special classes. Next is Unacademy subscription features. So why Unacademy? There are certain features which are very good or very much profitable for all of you. Now, what are some of the features of Unacademy that makes it so much special? First is you can learn from your home. You can learn from the comfort of your home. Okay, you will be having unlimited access to all the courses that you sign up for, and you will be taught by top educators of India at one platform. After that, you will be having a regular doubt clearing session and answer writing session. So at Unacademy, we just do not have the normal classes. We have separate sessions for doubt clearance, in which all the doubts you can bring it up to your educators, they will be clearing it. And also we have separate answer writing sessions which tell you that how to write your answers in a way that gives you maximum advantage or profit. Next, we have the exhaustive coverage of syllabus, and you are under the mentorship or guidance of your educators, right? Okay, you will also be getting all the study material in the PDF format, and of course, you will be getting all the practice tests so that you can practice and you can see and you can improve your performance accordingly. Then we also have live test and the batch courses. Okay. Apart from these things, there are daily practice section, weekly mock test series, live quizzes, daily MCQ, and subjective test series. So whole package you are getting at Unacademy plus subscription. Okay. Now, what you can do is you can choose a subscription plan. The plans are available for 3 months, 6 months, 9 months, whatever time duration you want to take. Just take it, and you can use my code, that is RITIKACLIVE, and you will be getting an instant discount. Okay, so you can choose the plans, okay, according to your convenience. You can use my code and then you can proceed. All right, now let us proceed with the next law, that is the Boyles law. So that is very first law, okay, of our gaseous laws. Now, what does Boyles law states? So there was a scientist, a student whose name was Robert Boyle. He studied the relationship between pressure and volume of a gas. Now Robert Boyle, he found that if we keep the temperature a constant quantity, then the volume of any given mass of gas, it will decrease by half if we double the pressure. Okay, and it will become 4 times of its original volume if we decrease the pressure to 1/4. So all in all, in easy language, he told that volume of any given mass of gas, it is inversely proportional to the pressure. The conditions are constant temperature. Okay, so what did Boyle say? Boyle said that volume of any given mass of gas, it is inversely proportional to the pressure at constant temperature. So what are the things that that are to be noted over here? That volume and pressure, they are inversely proportional, and here the temperature is said to be constant. Okay, it is kept as constant. All right, now let us derive the equation or mathematical expression. Okay, now let's suppose that we are having a gas, okay, which occupies volume. Let's say we are having volume V1 at pressure P1. Now, according to Boyle's law, what is it telling us? That V1, okay, the volume, it is inversely proportional to what? It is inversely proportional to pressure. All right. Now, if I remove this proportionality sign, what I will have? V1 is equal to K upon P1. Okay. Now, here K is a constant. Correct. Now, if I change the volume, if volume is V2 at pressure P2, what's the condition? The temperature is constant. So that is a very important statement. The temperature, it needs to be constant over here. Now what we can write? We can write V2 is inversely proportional to pressure. Okay, and similarly we will be having V2 is equal to K upon P2. Again K is constant. Okay, so what we can write, V2 into P2 is equal to K. Okay, and from this equation and this equation we can write P1 P V1, I'm sorry. Okay, so we can write that P1 V1 it is equal to P2 V2, which is equal to constant. Okay, and what's the condition over here? That the temperature it should be kept constant. Hope that is very much clear. So this equation it is known as Boyles law equation. Okay, now what is the second statement that we can derive out of Boyles law? That the product of volume and pressure of a gas now what's the condition? Temperature is constant. Okay, so at a constant temperature is constant. Okay, so that is the second statement of the Boyle's law. Next is, okay, so that was a statement. Now if I talk about the significance of Boyle's law, okay, why we are or where we are using it. Now according to Boyle's law we saw that when we increase the pressure, what happens? Since they are inversely proportional, the volume decreases. Okay, that means the gas it is becoming dense. Okay, now we can say that at constant pressure, okay, at constant temperature, if the temperature it is kept constant, the density of any gas it is directly proportional to the pressure. Okay, now there is a reason why the mountaineers they have oxygen cylinders with them. So why? Because if I talk about the atmospheric pressure, okay, at high altitude, it is low. Okay, so atmospheric pressure is low at higher altitude, and that means the air it is less dense. And since air which is available over there it is less dense, which means it will be having less quantity of oxygen. So that means we are having less quantity of oxygen available over there for breathing, and that is why we need to carry the oxygen cylinders, and that is the reason why mountaineers carry oxygen cylinders with them. Hope that is very much clear to you. All right. Now let us quickly revise whatever we learned today, and then we will be moving on to some of the very important numericals from Boyle's law. Okay, so let's go back. First of all, we had a comparison between solid, liquid, and gases. So the comparison says solid, they have got a definite shape and volume. Liquids haven't got any definite shape, but they have fixed volume. And gases, no definite shape, no definite volume. The molecules of solid are tightly packed, but as I talk about liquid, the molecules, they are comparatively loose, and in gases, the molecules are far apart. Then the intermolecular space in solids it is minimum, and that means they are having maximum force of attraction between the particles. If I talk about liquids, their intermolecular space it is comparatively more than solid. That and because of this, the force of attraction, the interparticle force of attraction, it is bit less. And in the gases, the intermolecular space it is very high, and therefore there is no force of attraction. The solids they cannot flow. Liquids flow from a high level to lower level, and gases they can flow freely in all directions. Okay, now then we saw the composition of gases. So the gases it is composed of molecules which are in constant random motion, The gases, the particles exert pressure in all directions because their particles are in random motion, and because of this they collide with each other, they collide with the walls of the container, and that is why they exert pressure in all the directions. The gases, they are highly compressible, which means we can compress the gases, and also they are highly expansible. How? When we decrease pressure or increase temperature, the volume of gases increase, and that is how the volume can be expanded. Okay. After that, the gases, they have got low density. Why? Because the number of particles per unit volume, it is very less. Okay, and that makes the gases less dense. Next, we learned about diffusion. So, what is diffusion? It is a property by which the substances which are kept in contact with each other, they mix with each other by the virtue of molecular motion. So, the gases, they are having this property of diffusion. Okay. Next is the gases, they can be liquefied. Okay, because when we cool, the kinetic energy of gas, they reduce, and when we apply pressure, the molecules come closer and the gas liquefies. Okay, then we learned about the absolute zero, which is equal to minus 273 degree Celsius. And what is it? It is the temperature at which the molecular motion completely ceases on the Kelvin scale. Okay, then we learned about the gas law. So what's volume? It is the space occupied by gas. SI unit is meter cube. Pressure is the force that is exerted by gas on the walls of container. SI unit is Pascal. And last, temperature, it is degree of hotness of any gas. It is measured on Celsius or Kelvin scale. Next, we learned about Boyles law. So Boyles law says that the volume of any given mass of gas, it is inversely proportional to the pressure, the temperature being constant. Okay, so we got the expression P1 V1 is equal to P2 V2 is a constant quantity. We can also say that product of volume and pressure of any given mass of dry gas at a constant temperature is constant. Okay, now let's do some of the numericals based on the Boyle's law. Okay, so volume of a certain amount of gas at 25 degrees Celsius and 100 centimeter of mercury pressure, it is 80 milliliter. Okay, the gas, it is expanded to 160 milliliter, keeping the temperature constant. Calculate the pressure of expanded gas. Okay, now let's see what are the values given. First of all, we will just write. Okay, so let's write all the values which are given to us. So P1, it is given to us as 100 centimeter of mercury, and what is V1? 80 milliliter. So P1, it is 100 centimeter of mercury, and V1, it is 80 milliliter. Then P2 we have to find out, and the new volume, it is 160 milliliter. So V2 is 160 milliliter. P2 we have to find out. The condition that is given is the temperature, it is kept constant. So if temperature, it is kept constant, what law we are using? Boyle's law. Okay, which says P1 V1 is equal to P2 V2. Now let's apply this equation over here. P1 100, V1 80, P2 we have to find out, and V2 is 160, right? Now on transferring, it is P2, so P2 is equal to 50 centimeter of mercury. Okay, I hope this question is very much clear. There is no confusion in it. Next, let's talk about the second question, which says at a constant temperature, volume of a gas, it was found to be 400 centimeter cube at a pressure of 760 millimeter of mercury. If the pressure of gas, it is increased by 25%, find the new volume. Now let's see what are the values given first of all. So we have been given volume 1 that is equal to 400 centimeter cube. Pressure 1, it is given to us as 760 millimeter of mercury. Now it is told that pressure, it is increased. Okay, first of all, constant temperature is given. So that means Boyles law. Okay. Now if the pressure of gas, it is increased by 25%. Okay. So how to calculate pressure 2? So first of all, what is 25% of what was our pressure 1? 760. Okay. So if we solve it, that will be equal to 190. Now our new pressure, okay, that is P2 will be equal to 760 plus 190. That will be equal to 950. Okay. Now according to Boyle's law, we have P1 V1 is equal to P2 V2. Okay. What is our P1? It's 760 and V1 is 400. P2 is 950 and V2 we have to find out. Okay. Now if we go for the transferring, okay, and when we take out the volume, it comes out to be 320 centimeter cube. Okay. Now this is our volume 2. Okay. I hope that you might have got it. All right, moving forward, a very important information for all the learners of grade 7 to 12. Now, Unacademy is back with Unacademy Prodigy. Okay, so this is a test for all the learners of grade 7 to 12. Now, by enrolling in this test, students, you can win amazing prizes and scholarship while testing your mental ability. Now you can enroll yourself right now for free of cost. Okay, 3 tests have already taken place. Okay, now you can take the test which is on 13th of February. If you need more detail on this, you can click on the link in the description and you will be getting the whole information. Now the test, it is scheduled on February 13, and if I talk about the students of grade 7 to 10, the test is at 12 p.m. Okay, so kindly note down the schedule very carefully and please don't forget to enroll yourself in the test. Why to enroll? Because you will be getting exciting rewards in every test. Okay, you can win a 20 lakh college grant. Then you will be having rank 1, that is MacBook Air. The rank 2 and 3 will be getting Apple iPhone. Rank 4 and 5 will be getting Apple iPad. The rankers between 6 to 40 will be getting an Amazon Echo Dot. And the rankers from 41 to 100 will be getting Amazon vouchers. Also students, you will be getting the scholarship. Okay, so if you are having rank between 1 to 10, you will be getting 100% scholarship. If you possess the rank between 11 to 25, you get 75% scholarship. If your rank is between 26 to 100, you will be getting a 50% scholarship. If your rank falls between 101 to 200, your scholarship will be 25%, and all the students having rank between 201 to 500 will be having 15% scholarship. So kindly don't forget to take part and to participate in the test. Next, talking about the plus batches. So this is the batch that we have started. Okay, so this is a kind of crash course. Okay, now here, what are the things that we are going to cover? We are going to cover all the important aspects of your term 2 examinations, right? So here physics is taken by Ayushi ma'am, biology will be taken by Shikha ma'am, and chemistry will be taken by me. And students of grade 9 and 10, if you are subscribing for your grade, you will be getting the subscription of grade 10, 11 and 12 absolutely free. Okay, so this is the batch which is all subject batch in English. Kindly enroll into it because here you will be getting the whole revision Plus you will be getting all the important questions, you will be getting all the practical important questions, and also you will be getting your answer writing sessions. All right, so I hope that is very much clear. Now students, if you are confused about how to prepare, if you are confused about your journey, about latest offers, if you have any query about the subscriptions, you can just call on this number, okay, and you will be having a counselor who will get in touch with you and who will be clearing all your doubts. So please note down this number. It is 8585858585. Okay, so just call this number and you will be getting the counselor who will be clearing all your doubts of any topic. And if you are subscribing, kindly use this code to avail the extra 10% discount. Okay, now let's do one more question on this topic and then we will be wrapping up this session. Okay, now if the question says that there is a gas which occupies 800 centimeter cube at pressure 1, that is 760 millimeter of Hg. Now we have to find out at what pressure it will be occupying the volume 380 centimeter cube, and the condition that is given to us over here is the temperature is constant. Now see students, if the temperature is constant, we will be applying Boyles law, right? Now what Boyles law states? It states that P1 V1 is equal to P2 V2, right? Now what are our values over here? P1 it is 760, V1 is 800. Now P2 we have to find out and V2 is 380. Now if I transfer it, it will be giving me the value of pressure 2, okay, that is equal to 1600 mm of Hg, or we can even write it as 160 centimeter of mercury. So students, I hope that you might have got it, you might have understood everything that we covered in today's class. Now we will be taking this session further, and in the next class we will be having a discussion on Charles' law. Then we will be discussing the gas law, okay, the ideal gas equation. And we will be having some of the very important numericals from this topic. So I hope that you might have understood everything that we have learned today. Please try to attend the session next time because we will be having, or we will be moving further with the chapter. And please try to share the links as much as possible. Subscribe to the channel of the Unacademy. And if you want the PDF, you can download it. Also, if you need any homework or any help, you can join the Telegram channel. The link is provided to you in the description box. So we will be meeting in the next class, students. Till then, just keep learning, keep studying. I wish you all the very best for your preparations. We will be meeting in the next session. Thank you everyone. Please